hope you will be able to solve the questions and all. So let me share my screen. Okay. Is my screen visible to all of you? Can you see the white page?
Yes, sir.
All right. Okay, so let me start the session. And also, so in week 5, okay, in week 4, we saw, we moved on, discrete to continuous random variable. A single continuous random variable. We saw how to decide a valid probability density function, all right, and we saw how to find probability of a particular area and all those all things we have seen already. In week 5 we moved on how to find the expectation, variance and function of a continuous random variable. Also in week 5 we saw joint distribution of discrete and continuous. So what is something in week 6? So in week 6, so we will start with the jointly continuous random variable. Okay. So first thing we will see, the major thing, you can say the key title for week 6 is jointly continuous random variables. Okay. So in this we will see, what is joint density. First thing we will see this, we will try to understand. Next thing we will see, we will start with 2D uniform distribution. Okay. And if once we will finish this 2D uniform distribution, then we will move on. The key thing, how to find, most of the people, facing difficulty, but we will try to understand this kind of thing, how to find the limits for the double integration problem. Okay, because we are going to discuss the two continuous random variable. For single, we had only one, integration. Now we will move on to double integration. Then after this, we will see what is how to find marginal density. Actually, concept is the same. Whatever we have seen for 2D, 2D, two discrete random variable also. Then we will see what is the independence. And after that, we will see what is the conditional density. Okay. So for a single random variable, okay, if you have a single random variable, let's say I'm saying x is a continuous single random variable. Okay. Then how will you identify this is, for this x, you have a valid probability density function? What are the criterias? Anyone can recall?
The area, area under the curve should be 1.
First of all, this should be greater or equal to 0.
Total probability equal to 1.
Yeah, total probability should be equal to 1. Total probability area throughout the should be equal to 1. And third one,
Fx is piecewise constant.
piecewise continuous. Correct. Okay. So these properties we have seen already for a single random variable.
Sir,
So,
can you just recap what is
Another way also, if it is disjoint units probability,
sorry,
mutually exclusive events probability of A union B equal to probability of A plus probability of B. Is it for PMF or general?
this is for
Third
PDF.
condition I am telling. Third condition. for
See. Third condition is, see, piecewise continuous means suppose my random variable is defined as which has PDF something, let's say some a x square plus x for some support, let's say 0 to 1. Okay, from 1 onwards, 1 to 2, let's say some another thing is there. So it should be continuous for, let's say 0 otherwise, for this part and this part as well. That is the meaning. Okay.
okay. Pieces
Okay.
continuous is okay. That is okay.
Hmm.
What about the concept of the designed units, designed events? The A and B are designed units. P of A union B equal to. Is it must to satisfy that P of A union B equal to P of A plus P of B when A and B are?
That is different thing. See, here I'm talking about only the for to check the validity of probability density function, whether that is a valid PDF or not. Suppose I'm saying x is a continuous random variable with this PDF. Okay, some for this support there is some a x square plus x. For this support there is something, let's say x cube plus 2x, for example, just hypothetically. So whether this is valid PDF or not, that's the case. Okay, if you want to find probability of A plus B, probability, sorry, A union B,
Probability of A
probability
union
of,
B equal to probability of A plus B.
so that
Probability
is,
of A plus probability of B.
see, that is something whenever you have A and B are disjoint even, then you can write probability of A union B equal to PA plus PB. Okay, so that is different thing. Okay, here we are talking about, if I'm here, you can find something like this. Suppose I'm saying what is the probability that my random variable will lie in a particular support, then what you will do, you will integrate from here to here this PDF. Okay, that is something like, okay. So those, it will depend what is your support of x, how you are going to define your runtime variable and all. Okay, these three criteria just for checking the validity of your PDF. Okay, so same approach we will apply, is applied for jointly density in 2 dimensions also. Okay, since we have 2 random variables, so we are dealing with the 2D things. So if I'm talking about in 2 dimensions, okay, so when I will say, so let me write the thing. Suppose I'm saying a function, okay, a function is fxy is said to be a joint density function. I will say this is a joint density function if, first thing, the same approach, fxy should be greater or equal to 0. Okay, since this is 2D, so one integration sign, let's say I'm saying fxy, so one integration sign will be for x, let's say support is minus infinity to infinity. Okay, just, and another will be for y. So you have to do 2 times integration, and this should be equal to 1. And third one is this fxy is piecewise continuous in each variable, means for each variable it should be continuous. So thing is that you can check, right? First property, area under the curve, I mean total area should be equal to 1 and piecewise continuous. Here this joint probability should be greater or equal to 0, area total probability basically it should be equal to 1, and fxy should be piecewise continuous in each variable. Okay, fine. Are you able to relate? This is very yes, no?
Yes, sir.
Okay, so suppose I'm asking,
Second
let's say I'm saying,
part
sorry,
wherein you have done the double integration.
yeah, this here we are dealing with 2 random variables, right?
Yes.
So first integration will be for dx, second will be for dy. You can do a reverse order also. What I mean by reverse order, you can write fxy, first dy dx, but anyway you have to do for with respect to x as well as with respect to y. Okay, so it can be with respect to y, it can be with respect to s. The only thing you have to keep in your mind, if you are writing dx here, then first limits should be for x, and if you are writing dy, then these limits will be for y. Okay,
Yes, sir. Got it.
okay, suppose I'm writing fxy belongs to something a. Okay, then how will you find? Okay, can I write like this? Double integration fxy, let's say dx dy for this a. In general, if I'm talking about in general, I'm not going to take anything else, right?
Area.
Area for that particular area, right? For a single random variable, what we did, if I'm asking what is the probability a less than x less than b, what you will do? You will integrate a
A to
to
B.
b
F of
fx
X.
dx, right?
Yeah.
Whatever a is there, right? Whatever the limits is there. We will see some questions also. Okay. So what about support of x comma y?
What, sir?
Support of x comma y.
The basically combination of x and y where the probability is non-zero.
Correct. So it should be combination of x comma y such that this x comma y should be greater than 0. That is just a definition of support of your random variables. Okay. So let's try to do, let me take some example, then maybe that will give you some clear idea. So first example, I will take very simple example. Suppose I'm saying let x and y have joint density. Okay. fxy, x comma y. Okay. I'm defining this as a 1 and support of x is, let me take 0 to 1 and support of y is 0 to 1 and it will take value 0 otherwise. Okay. So here no complicated function. I took just simply 1. Okay. Joint density function is fxy is 1. Support of x is 0 to 1 and support of y is 0 to 1.
Sir,
All right.
what may support, sir? Is it the limits of the
Correct. I mean this part. Okay.
There you define support of is nothing but a set of all points which satisfies the.
Correct. That PDF should be greater than 0. See,
Yeah. Always probability is greater than 0. Then why we define that? Probability
See,
means always greater than or equal
that's
to
the
0.
see, that's the standard, you can say definition, right? See, in general, in discrete, what we are saying range of x, range of y, right?
Yeah.
In continuous, instead of range, we are saying support because we are interested in part, something you can say it's area, right? That's why it's just a terminology difference. Okay. So suppose my question is, let me ask, suppose I'm saying you have to find the probability that your x will be 0 to 0.1 and y will be 0 to 0.1. Okay. If suppose if you had single random variable, then what you will do? Just ignore this part. Then you will simply integrate 0 to 0.1 your PDF, right? In single. If just ignore for y for a minute. Okay. Now, since I have two random variables, we are dealing with 2D part, then what I will do, as usual procedure, it will be, I will integrate 2D part. Okay. So first I will, let me take limits of 0 to 0.1. For now, both is same. I will integrate these two. So first I have to integrate with respect to x and then I will integrate with respect to
0 to 0.
limits of y. Okay. Is this calculation correct? I mean, are you getting this part?
Yes.
Yes, sir.
Everyone is getting this part, which I'm trying to write here. How to write this kind of thing. Okay. So now just do this very simple calculation. So 0 to 0.1. What is this part? For now, we have only one, right?
Yes.
No complicated equations. It will be dy. Then this part.
Is it a uniform distribution in the square? Is it a square area? That's why you are writing.
Yeah, square idea. I took very simple.
Oh, okay.
function.
It is given.
Okay.
Okay. Sorry.
It's given. Okay. So it will be 0 to 0.1. And what will this part? It will be x, right? And 0 to 0.1 dy. Correct? This integration part, if you will solve this. All right? Everyone is getting this part, right? This black highlighted.
Yes, sir.
Yes, sir.
Yes,
Okay.
no problem.
So now what we have to do? Now I will simply substitute the values of upper limit and then lower limit.
Point
That's
one
the
into point one answer. That is point
yeah. Let's go step by step. Okay.
zero.
Yeah. Let's do in general for others also. So it will be dy. Now it will 0 to 0.1. It will be 0.1 dy. 0.1 I can take outside. It will be 0 to 0.1, again 1 into dy. So integration for this, it will be very simple. 0 to 1, it will be y, okay, and 0 to 0.1. Now what we will do, we will simply substitute the values of 0.1 minus 1. So it will be 0.1 into 0.1. So what will be the value of 0.0, 0.1 into 0.1 is, it will be 0.01, right?
Yeah.
Yes, no, that is the one way. Okay, it's a see, it's a straightforward uniform, right? So uniform is suppose I'm saying, suppose this is 1 and this is 1, this is my total region, correct?
Yes. Yes.
Correct. This
Yes.
is y, this is x, and what is the what is our interested part? So this, suppose somewhat, suppose 0 point here, 0.1 is here, and for example 0.1 is here. So this is the part in which I'm interested, right?
Yeah.
Correct. And what is the area of this square?
100th.
Sorry,
100th of the whole. 0.1 into 0.1. 100.
0.1 into 0.1, direct, right? You will get 0.01. Yes or no? The same answer which we got by doing the integration part. Okay, so you can cross verify with your approach here. All right. Now you will ask why we are doing this integration if you are able to apply the area formula. The thing is, for now it's a direct thing, right? It's a uniform part. What if you have some complicated, equation? Okay, so I'm just trying to give you the flavor of this integration, how to proceed, how to approach this kind of question. Okay, in a similar way, suppose I'm asking what is the probability that x will lie 0.5 to 0.6 and y will lie 0 to 0.1. Okay, I have changed the area part. Okay, so now let's try to do with the graph first, then we will cross check with the integration part, just to get the idea. So this is the whole region, right?
It is
1
still
to
going to
1,
be the same
Rectangle.
0.01.
and x is 0.5. Suppose this is 0.5 and y is 0.5 to 0.6 and y is till 0.1. So what is our interested part? This only,
Oh,
correct?
5 only. Okay.
Right? You can see x is 0.5 to 0.6, y is 0 to 0.1. Yes or no?
Yes, sir.
So what will be this area?
It is again the same 0.01.
0.1 into 0.1 equal to 0.01.
0.01.
Right? You are getting the things, right? Now this was the uniform. This was the uniform part you were able to do. Let's try to do with the integration. Okay, now what should I write? So first integration, let's say I'm writing for x, so 0.5 to 0.6 fxy x comma y dx. Let's separate this for now, and next integration will be for y, which is 0 to 0.1. All right, it will be 0 to 0.1, and inside the bracket 0.5 to 0.6, 1 times dx, correct? Again it will be 0 to 0.1, and what will be this part? Anyone? What will the integration of 1?
That will
With
become x. So
x.
0.6 minus 0.5.
Correct. Okay, I'm just doing step by step because so that you should get more idea. Now I have to substitute the upper limit minus lower limit d of y. Now it will become again 0 to 0.1, 0.1 dy. You can take 0.1 outside. It will become 0 to 0.1, 1 into dy. Again it will become 0.1 y, 0 to 0.1. Now you can see 0.1 into 0.1, which is again 0.01. Okay, which is the same as this. Now, some rough idea is clear how to start with the 2D integration. Everyone?
Yes. Yes, sir.
Yes. Okay.
Yes, sir.
Now, if that is okay, in the same problem, okay, let me write the problem itself. Let's try to discuss third part of the same problem. Now, my probability was very straightforward. Let me change a bit. Okay, this was the case. Okay, so okay, let me ask, what is the value of probability x greater than y? Okay, initially you saw the very good thing, right? So first of all, what is the good approach? See, you can simply draw the graph. See, I know this is line should be straight. Okay,
Upper triangle, something like that.
just try to make this line should be straight. Yeah, I will come to that. So this is 0, this is 1, this is 1. Okay, so this is my total part, right? In which now, so question is, so what is the good approach? So very first approach is, what should be your first step in this kind of question? Draw a line for equal to means draw a line x equal to y. Okay, once you will draw x equal to y, so this will be some sort of x equal to y,
Yes.
correct? Yes or no?
Yes.
So there are two approaches to proceed with this kind of questions. So which region will be greater than y? This below triangle or above triangle? Just think a bit. And
Lower triangle.
lower
Lower.
triangle, right?
Yeah.
Yes.
Everyone would agree with us? Yes, no?
Yes.
So lower triangle is our interest part, right? Interest in which we are interested, right? So what is approach one is, I'm interested in probability that x greater than y. So if you focus clearly, so this is a triangle, right? And what is the area of a triangle? Half
Half base.
into base, okay, into height, right? So half, what is the base? Is 1. What is the height? Again 1, right? Base is this 0 to 1, height is again this part, right? Which is also 1. You can see my pencil sign, right? I'm talking about this part. Yes or no? So probability is half. Correct? Yes,
Yes, sir.
no? All right.
Yes. Yes.
This part is okay, right? Let's start with the approach 2. Okay. So what is the second approach? So second approach, I told you in second approach, draw a line for x equal to y. Sometimes you will get x greater than 2y, x less than 2y, and all. Accordingly, we can draw the line. And second step is, this is step 1. Second step is find the limits of, x and y. Okay. Now this is the part where you have to a bit careful. Okay. So how to find the limits of y? So just keep in mind, whenever if you want to find the limit of x, okay, for this part, then draw a parallel line to x-axis. If you are interested to find the limit of y, okay, see, for this region, you can't take 0 to 1 for x and y both, right? Would you agree with me? You cannot take, right? Because this is not something we are doing the things, right? This is not, we are interested only this part only. Are you getting my point? Okay. So let's say, first I will start with the find the limits of y. So what you have to do to find the limit of y, just draw a parallel line to the y-axis, okay, in the given region. If you will draw a parallel line to y-axis, let's say this red line here or here somewhere else. So what will be the limit of y? So this parallel line is going from where to where? What will be the limit of y at x-axis? Tell me.
1, sir.
0 to y.
0, right? At x-axis limit of y will be 0, right?
Yeah, yes, sir.
And what is from what is the last limit? So this red line is going till line x equal to y, right? That means value of y is x, correct? So
Yes.
limit of y will be x and 0 to x, and for x you will take the whole limit, which is 0 to 1. So what will be your integration part to calculate probability x greater than y? It will be first, since you are taking y with respect to y, it will be fxy x comma y. So for y, it's you will integrate 0 to x, okay, and then for x you will integrate till 0 to 1. Is this okay? Yes, no?
Can you explain that limit part again? Limit of y.
Yeah, so limit of y, you can see, if you can start with the finding the limit of y first, or else for with respect to x. So if you see, if I want to find the limit with respect to y, then I will draw a parallel line. You can say a parallel strip to the y-axis, right, in the region where we are interested. Okay, so if you can see this red line. Okay, so from where to where this red line is going? 0 to x, right?
I'm not getting it. Sorry.
See, what is the limit of y on x-axis?
Zero.
See, what will be the value of y
Yes,
when you are going from one end of the line to the other end of the red line?
correct.
So
Acha,
it is
acha, got it.
What is the limit of y at x-axis, right? So this is, I'm going here to here, right? Okay.
Yeah.
So what is the limit of, see, if I'm saying y equal to 0, that means x-axis I'm talking about, right? So, correct?
Yes. Yes.
And from where to where this is going? So this line, this black line is what? This is x equal to y line, right? So what is the value of y here? X, right? So that means limit of y is 0 to x, and limit of x, I will take the whole x, right?
Got it. Thank you.
Correct?
Yes.
Now, okay, I will take the limit of x as well, so that it will be clear in a minute. So now you can see I am going to integrate with respect to y first. That's why I took the limits of y here. Okay, I will integrate this, and then I will take the limit of x. Let me take x also, so that it might be clear. So if I want to take the limits of, let me draw the graph again. Okay, here only. So suppose I want to find the limit of x first. Then what I will do, as usual, I will draw a parallel line, or you can say strip, with respect to the x-axis, right? Then my line will be something like this, correct? Yes or no?
yes, sir.
Correct. So from where to where my limit of x will be? So x is going to this line, and this line is what? X equal to y line, right? So limit of x will be y to
Y to
1.
1.
Right? Everyone is getting this blue line part. So limit of x will be, if you want to start with limit of x, then my limit of x will be y to 1, and limit of y I will take total
0 to 1.
0 to 1. So one limit you have to find, you can start with by drawing a parallel strip. Either you can start with the y-axis, and then you have to integrate with respect to whole support for another random variable, and or else if you are going to start with x-axis, then you can take y to 1 for this particular part, and for y you can see, for y total support is 0 to 1. Okay, everyone got this idea, this y to 1 thing? Okay, what will be the integration part here then?
Sir, why do we take the entire range for the second variable?
Okay, how will you find then probability? Probability should be some, okay, I'm not going to depth into for now. As of now, I will come to that point just to give an idea. Okay, so since I'm taking y to 1, right, for one random variable. Okay, tell me, if I'm taking y to 1, then what will be the limit of y? I'm going to integrate for 0 to 1, right, for whole region.
0
Okay,
to
one more thing. Yeah, go ahead. Yeah, someone was saying something.
limit of y is 0 to x.
Yeah, 1 second. So okay, I will come to that one. So this dx, it will be y to 1, because I'm integrating, and it will be 0 to 1 dy. Okay, one thing you can keep in mind. Now I will come to that point in that region behind and derivation part actually. So thing is, suppose you are integrating with this part, okay, this dx. In terms of you will get values in terms of y, yes or no, if you'll integrate this part, because there is y limit, right? If
Yeah.
you will put the whole limit of y, only then you will get some probability part, right? Some value. For now, I'm not saying this is the particular region. I'm just giving you just a flavor. Okay. Same thing here. You can see if you'll integrate with respect to y, you will get some value in x, right? That's the x something, right? Okay. If here there will be some function of x, you will not get a particular value. Okay. I will come to that point in a minute. Okay. But for now, is this okay to all of you? This finding the limits. If it's not, don't worry. We will. I will take some other examples as well. Okay. Is this fine, right? Are you
Sir,
getting? Are
Sir,
you getting?
sir, one doubt.
Hmm.
Sir, in this case, y can be written in terms of x and x can be written in terms of y.
Yes.
What if we cannot write y in terms of x?
Nothing will be happen. I'm just trying to give you idea how to find the limits of x and y. It's not like it will always be function of those things. Okay. Okay.
sir, is geometrically, if we take one of the lines, either if we take red or the blue one, and the height thing, I understand why we took 0 to y or 1 to x. But I think if we let it go all the way, like from the entire left to entire right, or maybe from entire 0 to entire 1, is that the reason why the other one is allowed to be 0 to 1? Like it's allowed
That's
to
what.
span the
Correct.
entire thing.
Yeah. See, if you see, one thing you are doing, you are finding the region. Another thing you are, see, if you I will draw the parallel line with respect to x. I can do this one also, right?
Right. I get it.
I can draw here also.
Yeah.
I can draw here also. At the same time, I will get y21, y21, y21. So for that, y will be, you will integrate throughout the support of y.
Okay.
That's what, right? You got the main point actually. Okay. So now similarly, you can see this red part. If you draw, you can draw the parallel axis to the y like this also, right? This also. And now you can see for whole things, if you are drawing parallel line with respect to y, what you are doing, you can then for x, you can take throughout the range, right? Correct. I think now is this okay?
Yeah.
Okay. So now you got this idea, right? How to find this. So let me solve this integration part, and then I will take some more example, okay, so that we can get some idea. Okay. So I will solve with either one, right? Both will give you the same answer. If you are interested, I can solve the both. Okay. But since this is the first, let me start with this part. So this is 0 to 1. This is y to 1, and fxy is what? 1 only, right? Correct? It was given in our question, this joint density.
Yeah.
0 to 1, and it will be x y to 1 dy 0 to 1, and it will be 1 minus y dy. Okay. Now you can see I have to integrate 0 to 1, only then I will get the value of some probability part. Okay. So it will be 0 to 1, 1 into dy minus 0 to 1, y into dy. So it will be y 0 to 1 minus y square by 2, 0 to 1. Just substitute the values. It will be 1 minus 0 minus 1 by 2 minus 0. So it's a 1 minus 1 by 2. It will be 1 by 2. So you can see this 1 by 2 is the answer, because when we applied the area part also, we got the same answer. Okay. Do you want to let me solve this also, so that you can get the idea from the both, you will get same answer. So limits is 0 to x, whether you are going to start with y limits first or x. So here it's a y. Okay. And for x, it's a 0 to 1.
No,
dx.
sir. It is dx, no, sir. Reverse.
No. It's the limit of y. This 0 to 1 is limit of y.
Oh.
Okay. That's why I took. Here you can see y to 1 is limit of x. Understood? Correct? Yes, no?
Yeah.
Correct? All right. Now, so it will be 0 to 1 and 0 to x, since it's a 1 dy, you can simply put a bracket to get just, I mean, to distinguish between these two. So if you integrate 1, it will be y 0 to x dx, and 0 to 1, and it will be x minus 0 dx, right? So you got the idea, right? So what we have to do, we have to substitute the upper limit where we have x y. Okay, so I got 0 to 1 x dx, it will be x square by 2, 0 to 1, and it will be 1 by 2 minus 0, which is 1 by 2 again. So you can proceed with anyone. I mean, if you like to draw parallel line with respect to y, go with that. If you are interested to draw a parallel line with respect to x, go with that. Okay, is this okay? Some rough idea is clear?
Yeah, wanted to ask that approach one can be used like in any way.
You can use, but what if you have some not suppose you didn't get any proper region?
Yeah.
Okay, then you can go with this. Okay.
Yeah, got it.
So
Which,
can you write one hypothetical function fxy?
yeah, I will come to that one. Let me start. I will go step by step, right? So since no one have watched the content, that's why I'm going very simple function. And okay, this is
Sir,
not
I'm
a
just asking my doubts, sir.
yeah, I will go. Just wait for a few minutes. Okay, let me proceed the thing. Okay. So okay, let me ask what if I'm saying you have to find the probability that x greater than 2y. Okay, initially it was only x greater than y. Okay, then what, let me draw the graph again. So this is x and this is y, right? And what will be the graph of x equal to y? This is 1, this is 1, this is my total area. What will the x equal to 2y? What will the
Basically, it's also a straight line passing
straight
through,
line, but
passing
little
through,
bit below, right? Not,
slanted towards x-axis.
yeah. I mean, it should be, yeah. Now you are getting the idea. It shouldn't be like this totally straight, right? Maybe let me draw something like this. Okay. Would you agree with me? So this is x equal to 2y line, correct?
Yeah.
Now,
Yeah.
so
Yes,
what is
sir.
the, okay, so
Sir,
what,
maybe
yeah.
just one quick suggestion, sir. If you draw both x and y to the same scale, then it will be more clearer for somebody if somebody is in doubt. Just
same scale, like,
in the sense, 1 unit on x-axis, if you make it same as 1 unit on y-axis approximately, then
yeah, I'm trying to draw actually here.
yeah,
I'm not
no
able
problem,
to
sir.
draw.
Yeah.
Maybe, okay, let me retry.
Yeah, no problem. No, actually, if somebody is in doubt, it will help them.
Yeah, I got your point. Actually, by this writing device, I don't know why it's not
Yeah, I know, sir.
coming.
No problem. Yeah, no problem.
So suppose this is x, suppose this is y, suppose this is 1, somewhat. Is this fine now? I think
Perfect.
it's
Yeah.
perfect. Right. So this is my total area of interest, right? Now this seems square somewhat, right? So now x equal to 2y, let's say this. Okay, so again, it's not coming properly, but just try to adjust somewhat. Okay, just try to understand. So
Yeah.
this is 0. Okay, now, so what is very first thing we have to do whenever you are getting x greater than 2x less than 2, draw a line x equal to 2y, which we have done. Second thing, find the limits. Okay, so let's try to find the limits first thing. So let's say I will start with the limits, limit of y. So what will the limit of y? For this, what I will do? Okay, first of all, what is the x greater than 2y region?
Correct. It is the bottom one again.
This bottom only, right? Now, if you see x greater than 2y, I'm interested to find the limit of y. I will draw a parallel line to y-axis. Correct?
Yes.
And I can draw from here, anywhere, right? So if you see, if you will draw parallel line to y-axis, what will be the limit of y? It is going from, at x-axis, it will be 0. And this line is x equal to 2y. Then this will be y equal to x by 2. Everyone is okay with this? So limit of y will be 0 to x by 2. Yes, no, is this clear to all of you?
Yeah.
And limit of x will be 0 to 1. All right. So what you will do to find this part, probability that x greater than 2y, okay, now it will be integration of 0 to x by 2 fxy x comma y. I should write dx or dy?
dy.
Dy, because we are integrating with dy first, then 0 to 1 dx. All right. Now, can you apply the area of triangle here?
Yes, we can apply the area of triangle here also, sir.
Right. Then what will be the height?
The height will be x by 2, no, sir.
Height is
Base is x, and height is x by 2. That is half.
1 by 4. Your answer should be.
Yes, correct.
Okay. Let's try to cross verify. Okay. Now, okay, let me find the limit of x also. Then we will proceed. Okay. So that because we have. Okay, if I will start with the limit of x, then what I will do? I will draw a parallel line to x-axis. Okay. Then what will be the limit of y? This line is x equal to y. So this will be 2y to 1. See,
Yes.
value of x is here 2y, right?
Yes.
Are you getting my point? So limits for x will be 2y to
1.
And limit of y will be as usual 0 to. Is this okay? Are you getting, everyone is getting this part, right? The how to draw this parallel line and all. So what will be the, again, if you want to find the probability x greater than 2y, I will integrate 2y to 1, this joint density with respect to x first, then with respect to y 0 to. Is this okay? Everyone is able to
Yes, sir.
connect?
Yeah.
Okay. So let's solve this. Okay. See, in the previous problem, I solved both approach, right? This one with respect to y first, then after that x, with respect to x, and then after that y. In both way, we are getting the same answer. For this problem, I will take any one. Okay, you can cross check. Both way, you will get the same answer. Just for saving time, I will go with this. So probability x greater than 2y, we have what are the limit? 0 to x by 2. So 0 to x by 2, fxy was 1, dy and dx 0 to 1. So you can see 0 to 1, and it will become x 0 to x by 2 dx, and not x, this will be y, right? Okay, 0 to 1, and if you substitute the value, you will get x by 2 minus 0 dx, and it will be 0 to 1 x by 2 dx, and 1 by 2 I can take outside. I will get 0 to 1 x dx. It will be 1 by 2 integration of x is nothing but x square by 2, 0 to 1. Okay, now it will become 1 by 2, and 1 by 2 minus 0, which is 1 by 4. Okay, I think this is the answer. Okay, is this all right?
Yes, sir.
Yes, no?
Perfect.
Okay.
Yes, sir.
Perfect.
All right.
So you got the idea, right? How to draw the strip and then find the limits. Okay. Okay. Do not worry. I will take some other examples also so that it should be more clear. Okay. So once you will start watching lectures, right? I hope you will get some clear idea about this again. So next concept is called 2D uniform distribution. Okay. So in 2D uniform distribution, this you can find a bit a different concept, but anyway, it's a very simple thing. We will try to understand. So what is the concept behind it? Suppose I have some fixed region. Okay, let's say I'm some fixing some region which is, let's say, D. Okay, in R2. Okay, and I'm saying what is the total area? The total area is modulus of D. Okay. Now, suppose I'm saying I have x and y.
Sir, what is modulus, sir? Why modulus?
Modulus means, let's say you got
I know, but why? Oh, so if we are in third quadrant and we may get
Correct.
negative, and so you are saying just modulus
As
of
of now, we are dealing with R2. Correct.
okay.
Okay. Yeah. So suppose I have two random variable x and y, which is uniform in that region T. Okay, for that fixed T. And I'm saying if they have some, I mean, then they have the joint density as I hope you are able to understand my writing here. Okay. So fxy, suppose how will you find the fxy? It says 1 upon this modulus of d, and this xy should be for that particular region d, and it will take value 0 otherwise. Okay. It will be clear in a minute. And what is your d actually? So d you can define as nothing but something like that. A and A and B, then product of C and D. What is the meaning of this particular part? This means the value of x comma y such that your x will be between A and B and y will be between C and D. Is this notation clear? This A and B means your x is lying between A and B, and this C comma D means your y lie between C and D. Okay. Okay. Yes. No. You can see simply say yes. No. Only then I will get idea whether you are getting or not.
Yeah, yeah.
Okay. This is
Yes.
just a notation. I'm just trying to explain. So suppose.
Teacher,
Sorry. Yeah.
sir, could you please show that definition what you wrote for some region this one?
Yeah.
Okay.
Okay. If you want to
Okay,
take
join hands.
screenshot, do not worry about this. I will upload the PDF for itself. Okay. Just for now, just try to understand. So suppose I have a sub region. For any sub region, let's say A of this D. Okay. If you want to find the sub region, there is sub region of A, and I am interested to find the probability that x comma y will belongs to in that particular sub region. Then how will you find this part? Actually, this modulus you can treat as a area of D. Okay. Means I'm saying modulus of D means you can treat with the as area of D. Okay. That's the meaning as of now. You can keep in your mind. So what is this part? This means I'm saying mod A divided by. This means what is the meaning of this? Area of D. Sorry, A divided by area of D. Okay. Okay. For any sub region means you want to find the probability that xy belongs to in that particular sub region. Okay. Now let me take one example. Maybe that will give you more idea. Okay. So you can see how to find this joint density for this fixed region 1 upon this mod of D and all. Okay. Let me solve this problem. Suppose I'm saying I have x comma y, okay, which is defined as uniform. And how this is defined as uniform? Let's say I'm saying 0 comma 1. You can say Cartesian product of this 0 comma 1 and 0 comma 1. Okay, let me take another color. Union of, okay, 1 comma 2 into 1 comma 2 and union of, let me take as a 2 comma 3 into 0 comma 1. Okay. Do not worry about this. I took only here two things and but okay. So what is the interpretation? If I'm writing A comma B into C comma D, that means x will lie between A and B and y will lie between C and D, right? That is the interpretation. Yes or no?
Oh.
So okay, right? So let me ask the question. Suppose I'm saying draw the region and find first find this joint fxy. Okay. Also, suppose my question is, what is the probability that x greater than y? Okay, so let's see the solution. So let me draw the region first. Okay, so if you will draw the region,
Sir, you're going to draw the region for what? For the
D,
XY.
for this uniform D.
Okay. Okay.
Okay. So this is my x, this is my y, right? I told you this 0, 1 means what? Your x is between 0, 1. This 0, 1 means my y is between 0, 1. This 1, 2 means my x is between 1, 2. Y is between 1, 2. And this 2, 3 means x is between 2, 3. And this y is between 0, Is this clear? The interpretation of this part?
Yeah.
Okay. Now, so maximum limit is 3. Okay, let me draw one. Just okay, give me 1 minute, please. Okay. So here, forgive me for by this bad drawing part. Okay, but let's try to understand. Redraw. Is this okay? Seems okay, or seems square unit something?
Yeah. Yeah. Okay.
Right?
No problem.
Somewhat is okay, right? Now,
Yes.
if you see what is this first part, 0 to 1, right? And y is also 0 to 1. That means I got this square. Correct? This part, right? 0 to 1 into 0 to 1. Yes or no?
Yes.
Yes, sir.
This is again union of 1 to 2, 1 to 2. So x is 1 to 2. That means x is going to 1 to 2 along with y is also 1 to 2. Correct?
Yeah.
Union of x is 2 to 3 and y is 0 to 1, right? So x is 2 to 3, y 0 to 1. So x is 2 to 3, that means this part. And y 0 to 1, that means this part. Is the region is clear to all of you?
Yes.
Okay, let me highlight with some other color so that our region of interest is this one and this one, because it's a union. So we are dealing with all these three and this blue highlighted part. Okay.
But the last 0 to 1 out maps to 2 to 3 we understand, but 0 to 1 out maps to.
So y is 0 to 1, right? You can see this is y axis, right?
Correct.
So if you are going axis is 2 to 3, and what is the y axis? This is a 1 for y axis.
Okay.
Okay. And 0 to 1, right? Because at the x axis y will be 0.
Sure.
Correct?
Thank you.
Right?
Yeah.
Now, so first thing, if you see what we have to find by the definition, I have to find the area of D, right? Correct? Actually, this mod D, basically you can say it represents the area of D. Okay. So what is the fxy? Fxy is 1 upon area of D, right? So what is my fxy? How will you find the fxy first? This should be 1 upon area of D. Okay. For this xy should belongs to D and 0 otherwise. Okay. So what is the area of D from here? Area of D is nothing but, okay. So what I will do, what is the area first square?
1 unit.
1 into 1, right?
Yeah.
Since it's a union sign, I have to consider the plus sign. Then for second,
1. Again 1 into 1.
Again 1 into 1. Plus for the third,
1 into 1.
So this is total 3
units.
3 units, right? Now, what is the fxy now?
Equal to 1 by 3.
It will be 1 upon modulus of D. It will be 1 by 3. Would you agree with me, to all of you? For the support, whenever x and y will belongs to this D, and it will take value 0. Otherwise, now you got your fxy, correct?
Yeah.
Yeah, yes.
All right. Okay, so this is an important concept. So for now, I can give you one thing, hint. This is important for your quiz to answer. Okay. Now, so my question was you to find the probability that x greater than y. Okay. So for this, what I told you, just draw a line for x equal to y. Okay, so x equal to y will be some sort of like this. It should be straight. Actually, I need to find out some other thing so that I can draw the region properly. Okay, this will be x equal to y.
Perfect. Yeah.
Perfect.
Yeah.
Now, so what we now tell me, what is the your area of interest? Below 1 or above 1?
X greater than y means below, sir.
Below 1, right? X greater than y is the below 1. Now tell me, I told you if you are interested in a particular sub-region of A, then what you have to find? So this mod means we are dealing with the area. So this will be area of A divided by area of D, correct?
Yeah.
So I'm interested in the below part. Suppose this is the thing, right? So this is the graph. I'm interested in these parts, okay? So that means what is the area of in which we are interested? So we are interested in the below part. That means I'm interested in this triangle. Yes or no?
Yeah.
Along with this line, right?
Yeah.
And this in this triangle.
Yeah.
Yes or no?
Yeah. And the last square.
And
the last square, third square.
So it will be 3 to 3 or what?
No, 2 to 3, sir. This last square.
Okay, so can you draw any region, or for that we need to do something else?
No, sir. This third square is there, no, sir.
It's a total area. I mean, total area of third square, because it will cover under this part. Okay.
No,
yes or no?
No, I didn't understand, sir, what you're saying.
See, we are interested in red dot line, right? Below this x equal to y. Right? So for this two triangle, for this line, you can say I can add area of these two triangle and area of this.
Correct.
Yeah, yes.
Are you getting? So basically this where I'm this drawing lines, these are the area in which we are interested.
Correct.
Correct. Everyone is getting?
Yeah.
Right, because we are interested in x greater than y, right? So if you see, so what is the case? If I'm interested in any sub-region A, then what you have to do? Sub area of A divided by area of D. So what is the area of D? Area of D is 3.
3.
So what will the area of A?
Is 2.
So basically, area of A divided by area of D. So let's try to find the area of A. So area of A will be what? So you can see, we have to find the, you have to find the area of first triangle. So what is the area of triangle? Half into base into height. So half, base is 1, height is 1, right? Plus, and for this triangle, second triangle, again half into base into height. Again base is 1, height is 1, because height is going 1 to 2 and base is 1 to 2. It will be again half into base into height plus this part
1 into 1. 1 into 1.
1, which is again 1, and area of D is 3. Right? So it will be 1 by 2 plus 1 by 2 plus 1 divided by 3, which is 2 by 3. So this is the probability for x greater than y. Is this okay? Everyone is getting this part? Yes, no?
Yes, sir.
Right? Some rough idea is clear to all of you, right?
Yes, sir.
Okay. Yes. Let me take another example that maybe that will give you the. Now you will tell me. Okay, I'm just writing. You will tell me how to find the region and all. Do not worry about whether it's wrong or correct. Let's try to, since we are doing first time. So let me define. I'm saying x comma y follow uniform. Yes.
Sir, could you please show that above part, okay, area of triangle, and then area of triangle, and then you took area of
square.
Okay.
Oh,
okay. Yes, sir.
Yeah.
Yes, sir. Got it.
Okay. What if I will ask x less than y?
It will be 1 by 3, sir.
It will be 1 by 3, because then
1 minus 2 by 3.
Correct. Yeah, correct. That's the very good approach. You can directly do 1 minus 2 by 3, because this x is less than y plus x is greater than y. In this case, will give you the 1, right? Or else, if you see, yeah, you have to find this area plus this area. So which is half into half plus half divided by 3. Understood?
Yes.
Now let me erase this because interested. Okay, let me write the question. You will tell me the suppose I'm saying x and y follows uniform D, and what is my D? Let me define D. I'm saying let's say D is 0 comma half, not 1 this time, into 0 comma half, union of, this is union sign, half to 1 into half to 1. Okay, so what is the meaning of this 0 comma half? Please tell me.
It is the along x-axis.
So it will be correct.
Yeah.
And this will be for
0 less than y less than half.
And union of this part half to 1,
1.
And this will be
Half to 1.
Correct. Now let's try to draw the region. It's a very simple thing. Yes. So it's x, it's b, y. So maximum limit is still 1 only. So let me draw this as a half, this as a 1. I think it seems square and so first is 0 to half and 0 to half. That means x is 0 to half, y is 0 to half. That means this square.
Yeah.
Correct.
That's perfect, sir.
Yeah.
Yep.
And another is so this we are done with this part, right? Another is half to 1, x is, and y is half to 1. So x is half to 1 and y is also half to 1. That means y is half to 1 means this part, and x is half to 1 means this part. So these two squares we have, right?
Yep.
Correct. Now
Yes.
this is the region, right? Now what will the area of D? Let's try to find. Yeah.
I have these 2 units. Sorry, half into half. 1/4. Yeah, it's total half unit.
Yeah. So for this half into half plus
half into half.
Half into half, right? Everyone is getting this part, right? So it will be 1 by 4 plus 1 by 4, which is 2 by 4, which is half. This is area of D. Now, if this is the area of D, what will be the fxy?
Fxy will be equal to 1 by 1 by 2. That is
2.
1 upon mod of D. I mean, area of D. So 1 upon 1 by 2. So you can see fxy is 2 for when xy belongs to D. And it will take value 0 otherwise. Now with the same condition, suppose my question is what is the probability that x is greater than y? Okay, so let's try to find out. So x is greater than y means what I will do, I will draw a first x equal to y line.
Yeah.
Right.
Yeah.
And x is greater than 2 means I'm interested in this below line, bottom part, right? So the area of interest will be my this triangle plus area of this triangle, right? So what will be the area? First thing, tell me area of A divided by area of D. So area of A, I mean the sub part in which we are interested. Yeah. Okay. So tell me what will be the area of A? Half into base. What is the base? Again half.
Half.
What is the height? Again half. Right? Plus
again
half,
same.
Half. So it's a, and what is the total area?
Total area is
1 by 2.
Half.
Right. So half will get cancelled out. It will be 1 by 4 plus 1 by 4, which is 2 by 4, which is again half. Right? Is the calculation correct?
Correct. That's correct.
Now, okay, what if, okay, that is the case. But suppose I'm not interested. Suppose I forgot the formula of area of triangle. Then I want to do with the integration part. Just for simply, I'm just giving to the idea. Then what you will do? What will the limit of y? Tell me. What I will do? I will draw parallel line to y-axis.
Yeah, 0 to x.
What will be limit of y?
0
to x, y-x, because this is the x equal to y line. And x will be 0 to
1.
But this
zero,
one second,
zero.
this 0 to 1, sorry, 0 to x will be only for this part. What about this part? This part, what will be the limit of y?
Half to 1.
No, half to y.
Half to x.
Half to
Half
x.
to x. So
Right? And limit of x will be?
It will be half to 1.
See, here it's wrong. Here it's wrong. It's a 0 to half, right?
Yeah.
And
Here
here?
half to 1.
Half to 1. Everyone is getting this part, right? Now you have to first find the area integration with this part plus with this part. Now it's not same. You got the idea?
Yep.
Correct. So what will be the probability x greater than y? Okay, it will be first 0 to x. Okay, fxy, x comma y, dy, and then dx, then 0 to half plus half to x, fxy, dy, dx, and limit of x is half to 1. Okay, so if you will integrate this, you want to integrate me or is it fine? Yes, no? If you are able to do, then we can discuss the another concept, right?
I think this is a simple, sir. No,
simple integration, right?
Yeah.
Okay. So the key thing is, see, integration, most of the people know, the key thing just to, identify the idea of, sorry, this.
Right limits.
Yeah, correct. Finding the limits. Okay. So this was about uniform, right? So I think uniform part is very easy, right? You might get some triangle, square, and all. Okay. What if you don't have if you have non-uniform problems, then how will you proceed? Okay. Here we had 2D uniform. What if you have non-uniform? Okay. Let me take something and then we will try to proceed with this part. Okay. Okay. One general, so far, some rough ideas okay to all of you? You can raise your hand or something. Okay. Only one people getting the idea. Two.
What is that, sir? What is the question?
My question is, so far you got some rough idea? Or,
yeah, perfect, sir. Perfect.
Yeah. Okay. Suppose you have 2D non-uniform problems. Okay. And it's not given any fixed D and all. Okay. Again, I will take very simple function and then we'll start the, we'll try to understand. Suppose I'm saying x comma y, okay, have joint density as, okay, what is the joint density? See, one thing you have to keep in your mind, in case of this D part, you have to find the fxy. What sometimes people make mistake, they simply find the area of D and they simply write fxy is 1/2. No, it's 1 upon area of D. Okay. So just keep in mind. So let's say I'm saying fxy is x plus y, and here x comma y is between 0 and 1, and it will take value 0 otherwise. So what is the meaning of this part? This means x is 0 to 1 and y is also 0 to 1. This comma means, okay, if there is any other relation, so it will be like 0 less than x less than y less than 2. That is the different thing. This comma means x and y both are between 0 and 1. All right. So my question is, suppose I'm saying you have to find what is the probability that x is less than half and y is less than half. Okay. And the next part is, what is the probability that x plus y is less than 1. So these two, we have to calculate. Then what will be the solution part? So what will be the first thing? To check, see, here I didn't mention whether it's a valid density or not. What you can check, area under the curve should be equal to what? Dx dy or dy dx, this should be equal to 1. Right? Or okay, now let's try to find out this part. Probability x less than half, y less than half. See, this part again you can do with the area part, because limit of x and y both are 0 to 1, 0 to 1. And but I'm just trying to give you the idea of how to proceed with integration part. Okay. So what is the meaning of this? See, here lower limit is not mentioned for x and y both. That means what? We have to take the whatever the lower limit is there. Okay, it's not mentioned. It's a 0.12 half, 0.22 half. Doesn't mention. It's a simply mentioned x is less than half. That means I have to integrate 0 to half this fxy x comma y dx and 0 to half dy. Okay.
Sir, I think you are breaking, sir.
Is it? Now is it fine?
Yeah, I think.
Okay, so this part is okay. Here, see, it's not mentioned x is from 0.1 to 0.5 or 0.2 to 0.5. So it's simply mentioned x is less than half. That means I have to take the lower limit of from the support of x, which is 0 to 1. So the x is less than half. That means I have to find the 0 to half and y 0 to half. Okay. Now what we'll do? We'll do the simple integration. Okay, we'll upload that PDF. Okay, so we have to do simple integration. So 0 to half, what is the fxy? X plus y, right? This is my joint density. So x plus y, let's try to integrate with respect to x, then with respect to y. So 0 to half, can I write like this? 0 to half x dx plus 0 to half y dx. Yes, no?
Yes.
And it will be 0 to half. If you will integrate this part, it will give you x square by 2, 0 to half. What if this y is a constant, right, for x, because we are integrating with respect to x, so it will become basically it will be y integration of 0 to half 1 into dx, which will give you y into x 0 to half. Okay, and overall dy. So now it will be 0 to 1 by 2, and it will become, you have to substitute the upper limit. So it will be 1 by 2 square, that is 1 by 4, divided by 2, that is 1 by 8, minus 0, plus y into, we have to substitute at the place of x, because we integrated with respect to x. So it will be y by 2 minus 0 dy. Yes or no?
Yeah.
Correct. Now it will be 0 to half 1 by 8 plus y by 2 dy. If you will integrate again, it will be 0 to half 1 by 8 dy plus 1 by 2 I can take outside, 0 to half y dy, and this part will become 1 by 8 into y. Anyone, if you are not getting this integration part, do let me know. Okay, I'm assuming this is a very first formula of integration, I think, right? So 1 by 8, upper limit 1 by 2 minus 0, it will be 1 by 4, and y square is again, if you substitute 1 by 2, it will be 1 by 4. So it's 1 by 16 plus 1 by 16. So 2 by 16, which is 1 by 8. Okay. All right. Yes, no?
Yes, sir.
Okay. Now, so this was the first part. Second part is what? I'm interested in probability that x plus y, less than 1, right? And we from the given question, this is x, this is y, x is 1, y is still 1. Okay, so this is my total area. Okay, what I told you to start, whenever you have been given any inequality, what is the first step?
Just
draw
assume
x
equal.
plus y equal to 1.
1.
So what will y equal to 1? This line or this line? X plus y equal to 1.
No, it will be some other line. Basically, yeah, correct.
This will be x plus y equal to 1. Everyone would agree with me?
Yeah, yes.
Basically, you can substitute x 0, you will get y 1. If you substitute y 0, you will get 1. Sorry, x equal to 1, you can simply. And what is the x plus y less than 1? less than 1 part region,
That below part, sir.
below part, correct? That is something we are interested here, right? Now, how to proceed? So first, what we will do, let's start. Tell me what will be the limits of y. Okay, first what I have to do to find the limit of y? I have to draw a parallel strip with respect to y-axis.
Correct.
So if I will draw a parallel strip to y with respect to y-axis, what is the limit of y?
Limit of y will be 0 to
0 to, and this line is x plus y equal to 1. So y will be 1 minus x. Everyone is getting this part? All right, see, this line is x plus y equal to 1. Then value of y will be 1 minus x.
Yes, sir.
Okay. And what will the limit of x? Again, 0 to 1 only.
Yes.
Okay. Now, what you have to do? I'm not going to do the now derivation. The derivation is same, just the limit change. So it will be 0 to 1 minus x, your fx y dy and dx 0 to 1. Yes or no?
Yeah.
Correct. Now let's try to find the limit of x first. See, you can go with the either approach. That I'm not saying you have to start with y. Let's try to go with the x. Then what I will do, I will draw a parallel line with respect to x. If you draw a parallel line with respect to x, then what will be the limit from where to where this is going? What
0 to 1 minus x.
Correct. So what it is going y-axis to here. So it will be 0 to x equal
y.
to 1 minus
y.
y. What will be the limit of y? 0 to 1. Then how will you find this part? Whatever there, it will be 0 to 1 minus y, my fx y, dx, and with respect to dy, 0 to 1. Would you agree with me? Now you got the idea how to find the limit and then proceed with this part?
Yes. And sir, could you show the previous calculation once? Yeah. How do I get that 1 by 4 plus 1 by 4 that?
Okay,
It's
so
half,
this
right?
this you can 2 you can say take outside. It will
Achha,
become 1 by 4. Y square, if you substitute 1 by 2 square, that will give you 1 by 4, right?
Okay, got it.
Got it?
Thank you.
So the next thing, let me take another example. Now I want to, okay, let me draw the only, you will tell me the region and all. Okay, I'm just hoping you are getting the idea. Do not worry about correct or incorrect. Just try to understand. Suppose my question is x comma y have joint density as, okay, let's say fxy x comma y is nothing but 4xy, okay, and limits of x is, let's say, 0 to 1, and limit of y is 0 to 1 and 0 otherwise. Okay, now let me ask you the question. I mean, question is the same, just change of PDF so that you can get clear idea. What is the probability x less than half, y is less than half? That means what I have to do? I have to integrate 0 to 1. Yes, right?
Yeah.
0 to 1?
0 to half.
0 to half for both cases, right? Because if lower limit is not given, that means I have to take the lowest from here. If rather this, suppose it's right, it has been written 0.1 to 0.5, then you will integrate 0.1 to 0.5, right?
Yeah.
And it will be fxy x comma y dx dy, right? Whatever the answer will be there. Okay. Now the same thing. Let me ask you, what is the probability that x plus y less than 1? Okay. So again, what will be the area? So this is your x, this is my y, this is 1, this is 1. So this is my total support. All right. And what is the x plus y equal to 1? Some sort of this. Okay. So this is x plus y equal to 1 line. So first thing, what will be the, I draw the x plus, oh, this is my area of, right, in which we are interested, right, area. So what will be the limit of x? Let me start in reverse order. So limits of x will be, tell me, what I will do, I have to draw parallel line with respect to x axis. So limit of x will be
0 to 1
0
minus
to,
y.
and
1
here
minus y.
x plus, this line is x plus y equal to 1. That means x will be 1 minus y, and limit of y will be 0 to 1. Okay. Now I think you are getting the idea. Now in the same part, in the same question, that is this part, x plus y less than 1 will be 0 to 1 minus y, 0 to 1, and 4xy dx dy, right? That is something I have to integrate. Now, in the same question, if I will ask, what is the probability that x greater than y? Okay. So, x greater than y means, let's draw the region again. X, this is y, this is 1, this is 1. So, x greater than y, so this is my total. And x greater than y means, first of all, I will draw a line x equal to y.
It is the upper triangle, lower triangle.
Lower region.
Lower or upper one?
Lower, sir.
Lower, right? If this is the lower, what will be the limit of x?
Limit of x is y to 1.
Correct. So y to 1, because this is going from this black line to this vertical line. So y to 1. Limit of y will be
0 to 1.
0 to 1. Then what you will do? Y to 1, 4xy dx, 0 to 1 dy. All right. What if I will ask probability that x less than y?
Excuse me, sir.
Yes.
Why don't we write y in terms of x? Why do we write x in terms of y?
When did you join the session?
Just now, 5 minutes back.
That's why. So I think you should rewatch the thing. So thing is that, let me explain. So you can go with either one. You can start with the limit of y also. So if you want to start with the limit of y, we have already discussed. You in both way you will get the answer. If you want to start with limit of y, then what you have to do? You have to draw a parallel line with respect to y-axis. Then limits of y will be, tell me what will be limits of y, from where to where this is going? 0 to x, because this line is x equal to y, and limits of x will be
0 to 1.
0 to 1. And then what you can do? You can integrate the same thing, 0 to x, 4xy dy first, then 0 to 1, then dx. So this integration part and this part will give you the same answer. We have already checked this part. Okay.
Okay, sir.
I mean, one basic question.
Yeah, please.
This upper triangle, lower triangle we design now is x plus. I mean, that can you say? I mean, the x plus y or x greater than y, which triangle?
Okay. How you are finding x greater than y and this part?
Correct. Yeah.
Okay, so what you can do, just simply substitute one value. Suppose I'm here, for example. Okay, and at this point, what will be the value of x here? More than 5.5.
Correct. Yeah. Right.
And what will be the y limit of y? It's not more than 0.5, right?
Correct.
So that means my x is greater than y.
Correct. Yeah.
Got it?
Yeah. Okay. Sure. Thank you.
So what if I will ask probability that x is less than y? Now this will be the upper triangle. Yes or no? See, if I'm here, x is less than y, right?
Yes, sir.
So what will be the limit of, let me ask you, if I want to find the limit of y, then what I will do, I will draw parallel line with respect to y-axis. So you can see if y is going from where to where?
From x to 1.
X to 1, because upper limit is 1, right? So limits of y will be x to 1, and limit of x will be as usual, 0 to 1. Yes or no?
Yes, sir.
So what you have to do? You have to integrate x to 1, 4xy dy, 0 to 1 dx. Yes or no?
Yeah.
And if you want to do in reverse order, then reverse order, I mean, if you want to start with the part that
You can just reverse the integration, sir.
correct. So limits will get changed, right?
That's it. Yeah. Limits will get changed and dx dy will interchange.
Yeah. So one more question, let me solve and then we'll move to the next topic. So, okay, everyone has pen and paper right now?
Yeah.
Yes, sir.
So suppose I'm saying fx joint density is k times x square y, and let's say support of x is 0 to 1 and y is also 0 to 1 and 0 otherwise. Okay. Then suppose my first question is find k such that this fxy x comma y is a valid joint PDF. Okay. So just find the value of k and let me know what will be the value of k. Okay, you have some 2 to 3 minutes.
So is k equal to 3?
Unfortunately, I don't know the answer. So I just gave you the question. I need to solve it.
Okay.
Yeah.
Integration. Integration will. No, it's not. Yeah, 6 is right, I think. Yeah.
So k is 3 or 6?
Okay, I think it's 6.
6. Okay, let's try to solve. Okay, or else if you are trying, I can wait for 2 minutes. That's not a problem.
Yeah, just give 1 more second, sir.
Yeah, sure, second. I will be back in 2 minutes. Okay.
Yeah.
Okay, it seems most of the people getting 6, right?
Yes, sir.
Okay, let's try to solve it. So what we have to do? We have to do area under the curve 0 to 1, 0 to 1 should be equal to, and I can take k outside, right? With dx dy. Okay, see, let me separate this so that so since this is I'm going to integrate with respect to x only, then what I can take y as a outside also. Yes or no?
Yes, sir.
Because you can treat y as a constant because you are going to integrate with respect to x only. So this is k 0 to 1 y. So this will give you x cubed divided by 3, 0 to 1, dy equal to 1. So k times 0 to 1 integration of. So it will give you 1 by 3, right? 1 by 3 minus 0, dy equal to 1. So it will be k by 3. So 0 to 1, y dy equal to 1. Now k by 3, this y will give you y square by 2, 0 to 1, this will be equal to 1. It will be k by 3. It will be 1 by 2 minus 0 is equal to 1. So it will be k by 6 equal to 1. So k will be 6, right? So final value of k is 6. Okay. So what will be your joint density now? 6 times x square of y, 0 to 1, 0 to 1. Okay. Now let's try to solve some questions for this part. Okay. Okay. So what if, okay, I will start with the same kind of problem, but we'll try to move with some twist part. Okay. Suppose I will ask what is the probability that x will be half to 1 and y is greater than 0. What does this mean? I have to integrate x half to 1. Yes or no? Yes, no, all right. Anything?
Yes, sir.
And limit of y will be 0 to 1. That is something you have to do. Would you agree with me? Are you there,
Yeah.
everyone?
Yeah.
Yes, sir.
Sure.
Yeah. So that, okay. So y greater than 0 means 0 onwards, and upper limit is 1. So I can take only till 1. Okay. Now the same thing. What will be x greater than y? Just try to find the limits. Okay. I will take one more problem so that it will give you the clear idea. X greater than y means, again, this is x 1, y 1. So this is nothing but x equal. Sorry. Should be straight. So this is x equal to y. What will be the limit of x? Sorry, limit of y, let's say. So limit of y will be 0 to x, 6x square y dy, and then you will integrate with respect to x, which is 0 to
1.
Now, tell me, maybe that will be a tricky part for a minute. Tell me, what if y less than x less than 2y? What is the meaning of this?
Y
less than x. Okay. Can I write like this?
Oh, x greater than, it means x greater than y, but less than 2y.
Can I write like this?
Yeah.
Okay. So what I told you, whenever you find inequality, just draw equality sign. That means what? Draw y equal to x, draw x equal to 2y, and then try to find out. Okay. Are you getting my point? So
yeah.
What is your so this is x, this is y, this is suppose 1, this is suppose 1, right? This is the total area. All right. So what will be x equal to y? So x equal to y will be some sort of like this.
Yeah.
You draw. So this will be x equal to y, right?
Yeah.
Okay. So here there is a trick you can apply. Rather than x equal to 2y, what you can plot? X by 2 less than y. Means y equal to x by 2. Means this will be line something like this.
Yeah.
Y equal to x by 2 or x equal to 2 by, both are right. Are you getting my point?
Y equal to x by 2, correct. Yeah. Or x equal to 2y. Yeah.
Yeah, or x equal to 2y, right? Right. Okay. So why I wrote like this? Just for whenever you are finding limits. So what is this part? X lies between y and 2y. That means my area of interest is this one.
Yeah.
Let me, right? Everyone is getting, right? Initially I took very simple example. Now I took this one so that you might be okay. So my area of I mean the area for which we have to find the probability is this one, right? So what you have to do, first find the limits of y. Okay. So for limit of y, what you have to do? You have to draw a parallel line with respect to y-axis. So what is the limit of y here? It is going from x by 2 to x. Is this clear?
Yes.
What is the limits of x here?
X is as always 0 to
0
1.
to
1.
1. Is this clear? The thing which we have find. Actually, I wrote y equal to x by 2. You can, this line is basically x equal to 2y. Okay, so I wrote just to get the y equal to x by 2. That's all. Okay, is this clear, right? What you have to do? You have to integrate x by 2 to x, 0 to 1, 6x square y, dy and dx. Whatever the answer you will get. Is this clear?
Yes, sir.
Right. So,
maybe one question. Is it?
Sorry?
Yeah, the x limit is it 0 to 1 or something, because the triangle, if you put a horizontal line. Oh, that's one other calculation. Okay.
Yeah. Okay. So x equal to 0 to 1 means you can draw parallel here, anywhere, right?
Right. Got it.
Okay. Yeah. Now, if that is okay, one more thing. Do you session at 8 in this session? Or
Yes.
Yes, sir.
Math.
Okay. Okay. Then let me cover accordingly. Okay. I mean, anyway, I will give you the idea of all type of concept. So next concept is marginal density. Okay. You have seen in case of what to say? Sorry, discrete part, right? If you are given two random variable, in case of discrete, the similar approach is there. Then if I want to find probability x equal to x, then how will you proceed? I have to do the summation over the range of y and this joint PMF. Yes or no? Can you recall, or you forgot? This is marginal PMF of x, right?
Yeah.
And in case of y, what you have to do? You have to do the summation throughout the range of x, this joint. Is this clear? Is this okay to all of you?
Yeah.
Okay. Now, what you have to do, as we know, in case of continuous, what we are doing, since see, integration sign is nothing but continuous summation, right? So if I want to find, let me write, suppose I'm saying this x comma y have joint density fxy x comma y, then if I want to find the when I will say x has the marginal density, then what you will do by using the above concept? By using the what if you want to find the marginal PMF of x, what you will do? You are doing the summation over the range of y and this joint PMF, right? What you will do? I will replace this integration with the summation sign, and I will do this integration. I will replace the summation with the integration sign, and I will do the integration for the support of y to get the marginal density of x. Would you agree with me?
Yeah.
Yes or no?
Yes.
Correct. Similar way, instead of summation, we have integration. In same way, y will have the marginal density as, if you want to find the marginal density of y, what you have to do? You have to integrate for the support of x with respect to x, then you will get the marginal density of. Is this clear? As we have seen already.
Yeah.
All right. So whatever the thing is given to you, you have to integrate with this part. Okay. Since we have very few minutes, so let me give you the just idea. I think more examples on this we can discuss in the next session, because you have session at 8. Okay. So this part is okay, right? Okay. Let me give you one flavor. Suppose this is fxy is given to us this part. Okay. And I asked, what is the f of x? Then what you will do in that case? Fxy was, this joint density was 6x square, 0 to 1 and 0 to 1. If I will ask, what is the fx of x? What you have to do? You have to integrate with respect to y. And what is the limit of y?
0 to 1.
0 to 1, 6x square y dy. And since you are integrating with respect to y, at the end you will get some function with respect to x, right? if you want to find the marginal density of y, you have to integrate with respect to x. All right? Yes or no? Clear
Yes, sir.
this part?
Yeah, yeah.
So next thing is coming. Next thing is just independence part. Okay. So when you will say two events are independent,
When their joint probability is same as the
marginal product of their marginals, right? In terms of probability, if I have event 2 and two events A and B, I will say these two are independent if A intersection B is nothing but probability of A into probability of B, right? Or else probability of A given B is same as probability of A, or probability of B given A is same as probability of B. Means happening or non happening of another event doesn't affect the happening of first event, then that means it's independent, right? Correct? Would you agree with me, right? So I will say if I have two random variables x and y are independent, I will say if this joint PDF of these two is equal to product of their marginals. Okay, if this case is true, you will say x and y are independent. Or by using this concept, you can say this conditional probability, let's say fxy equal to at a particular y, this is same as fx of x. Or fy given x equal to x, this y equal to fy of y. Right? Is this clear? Are you able to relate? So what you have to do, you have to, now you know how to find this is the marginal density of x, this is marginal density of y. You can find out and then you can proceed with the calculation. Is this clear?
Yeah.
Right? And the same way, right? If I'm interested to calculate the conditional probability, okay, in the next session, I think I will try to come up with question with the conditional probability. Okay. So conditional density is what? How will you define the conditional density? So probability that A given B is nothing but probability of A intersection B divided by probability of B. All right. So let me define conditional density here. Suppose I'm saying there is A or A such that I'm saying fx of A is greater than 0. Okay, forget about this. Let me write very simple thing. Suppose I'm saying I have to find fy given x equal to x at y. So what is the numerator part? Joint part, right? So it will be fx of y, x comma y, and then in the denominator, it will be fx of x. Yes or no?
Yes.
The only condition this fx of x should be greater than 0. And you know, right? Suppose you have been given this joint density and you have been asked this conditional. That means what? You have to calculate the marginal of x first. To calculate the marginal of x, what you will do? You will integrate the joint density with respect to y. You will get this fx of x. Yes or no? And similarly, if I want to do x given y equal to y at x, then what will be the numerator part? fxy, x comma y, and denominator will be fy of y. Is this clear? Yes, no?
For the marginal, is it respect to dy or dx?
Dy, right? You want to find the marginal density of x. To find the marginal density of x, what you will do? You will, okay, in case of discrete, what you are doing? You have to,
yeah, I'm summing over y.
Y. That means in case of continuous, you will integrate with respect to y.
Can you scroll down a bit? A bit up, actually. Yeah, okay, fine.
Fine, all right. In case of discrete, you can recall, right? So suppose this is x, sorry, this is x, this is y, 0, 1, 0, 1. Some values are there, a, b, c, and d. If I will ask what is the fx of x, then what you are doing? You will add a plus c, b plus d. What is a plus c? You are adding over the range of y, right? Correct? Then in case of continuous, your summation sign will be replaced by the integration part.
Yeah.
Clear? So how to solve this kind of question? So let me show you. Suppose I'm saying fxy. I will solve this question in a minute. Then you can go for the math session. I will not stop because that's also important. More or less, we have covered the concept. Just to some more problems based on independence and this. Okay, suppose in this case, I'm asking what is the probability that y is greater than 0.5 given that x equal to 0.5. Okay, means suppose I'm saying what is the probability that y greater than 0.5 given that x equal to 0.5. That means what? The numerator part is what? Numerator part is fxy is what? At 0.5 of y. Yes or no? Are you getting?
Y greater than 0.5.
Yeah, y greater than 0.5 means I have to integrate from 0.5 to 1. So this x equal to 0.5 means the value of this density at a particular value of x. Means if I'm writing, okay, this means nothing but here it means 0.5 comma y. Okay, so your density will be 6 times 0.5 square into y. Okay, so your numerator part will get changed by this one. Are you getting?
Yeah,
Okay. One second. Let me take very simple example. See, you will get confused. Let me take very simple example. Maybe that will give you the idea. So what if, suppose I'm saying, probability that y is greater than 0.5 given that x is already 0.5. Okay. Now is this okay? So this means what? Numerator part says x is greater than 0.5 and y is greater than 0.5. Both are greater than 0. Denominator part will be probability x greater than 0.5.
Yeah.
Now numerator part is what? It will be I have to integrate 0.5 to 1 this 6x square y with respect to dx and 0.5 to 1 with respect to dy.
Okay. Yeah.
Yeah, that's what, because I'm interested in the both part, right? I'm interested in joint. In the denominator, it will be 0.5 to 1 fx of x dx only, right? Because I'm interested in x part. Now, how to find this fx of x? To calculate the fx of x, you will integrate fx of y, x comma y with respect to dy throughout the range of 0 comma 1. Then whatever the value of this fx of x will be here, you have to then integrate 0.5 to 1. Is this clear? See, here you have to integrate 0.5 to 1 fx of x, right? To calculate the fx of x, we have to integrate 0 to 1 with respect to y, this joint density. Okay, let's do a bit. So this is 6x square y dy. Okay, 6 I can take outside, 0 to 1. Since I'm doing with respect to y, 6x square I can take outside. So it will be 6x square. It will be y square by 2, 0 to 1. It will be 2 to 3, right? It will be 3x square, 1 minus 0. So fx of x is nothing but 3x square. So now what you have to do, your numerator part will be 0.5 to 1, 0.5 to 1, 6x square y dx dy. Denominator part is, since probability x greater than 0.5, so 0.5, 3x square dx. Is this clear now?
Yeah, getting clear.
Right? Right?
Yeah.
Okay, that's the something you have to do. So the key, one thing you have to keep in mind. So you have to, this is fx of x. If you suppose I have changed like this, x is greater than 0.5, given that y is greater than 0.5, then numerator part is same, but denominator part will be 0.5 to 1 fy of y dy, right? Then you have to find the f of y. How will you find f of y? You have to integrate 0 to 1, same thing with respect to x. Then anyway, I think it will be 3y square, if I'm not wrong. Clear?
Yeah.
Okay, all right, everyone.
Yes.
Thank you.
Okay. So I hope you got some sort of idea for the week 6. Okay, just try to use this and try to solve more questions. Okay,
So are these all the topics?
Yeah, that's all the main topics. I just skipped the examples in case of independence and marginals. I want to take some more examples, but anyways, you have session at 8 for maths. That's why I'm closing. Otherwise, okay. So we'll come to some more questions in the next session. Okay. So key idea is to find the limits and all. Okay. I hope this conditional probability formula is clear to you. Okay. Then we can. Okay.
Yes, sir.
Yes. Thank you,
Alright?
sir.
Yeah.
Yes.
Okay.
Thank you, sir.
Thanks all. Bye. Bye.
Thank you, sir.
Yeah, so someone is talking about some. I mean, Ayush is talking about notes and all. We'll upload it. Ayush, do not worry.